Okay, so today we will be looking at solving some differential equation. So now let us look at one simple system which is basically the simple harmonic oscillator. Okay. So in the case of simple harmonic oscillator, so what is the differential equation which you can write down? Can you tell me? Yeah? D square y by dt square is equal to omega square y. So basically what we are having is f is equal to minus kx. Okay. So the force is minus kx. So in that case this is x, right? And so what is F is equal to? Force? Force? Yeah? So F is ma, a is d square x by dt square, right?
Yes.
Yeah. So what you get here is now minus k by m x. Is it correct?
Yes, sir.
Okay. So you have to solve this equation. So is it possible to solve this equation numerically, analytically?
Yes, sir.
Okay. So what you do in that case? So what is the solution?
Sin omega, a sin omega.
X is equal to a sine.
Omega t where omega is equal to root k by
Can be a general solution, no?
b cos omega.
B cos omega t. What is omega in terms of k? So what is omega km relation?
Omega equal to root k by
Okay. So to solve this equation, how many initial conditions are required? Two initial conditions. So what are those two initial conditions?
initial position, initial.
Yeah, x at time 0, okay,
X dot
and dx by dt, or x dot at or you call it as a velocity, okay. So x dot, okay, at time t equal to 0. So if these two conditions, if two initial conditions are given, you can actually find out this a and b, right? There are two unknowns here, a and b. That unknowns you can get it in terms of x and x dot. Okay. So for various initial conditions you can solve this analytically, explicitly you can solve this. So what will be the velocity? Velocity will be the x dot, that is, take the derivative of this with respect to time. So what is the energy? What is energy equal to?
Net dot square by 2 plus half k square.
So basically p square by 2m plus half kx square, right? Is it correct? Yeah. So
Yes, sir.
yeah. So then what is p? P is, so now you can, so p is basically m mx dot. Okay, so you can p, and so if I know x and x dot, I can find out E. Okay, so what is x E as a function of time? So p at 0 and x at 0. Okay, so energy at a time t equal to 0 is p at 0 square divided by 2m plus half k x at 0 square. Okay, so what will be E of t equal to?
E of 0.
E of 0. Okay, because it is a time independent Hamiltonian and a conservative system, so energy is constant. So E of t equal to E of 0. So you can actually, given the initial conditions x of 0 and x dot of 0, you can actually solve this equation explicitly analytically and find out, you can actually plot x of t versus t and p of t versus t, okay, and energy as a versus t. So energy will be a constant, right? So it will be constant, and x and p will be changing sinusoidally. So this is a simple problem we have taken to do this calculation numerically, but we will extend this to a different problems, but the same techniques you can use. So that is the reason I am using initially a simple problem. So how do you solve this numerically?
You can use RK4 method to solve.
Okay, so there are different ways actually you can solve this. So now let us just call y1 as x and y2 as x dot. Okay, you call y1 as x and y2 as x dot. So what is d y2 divided by dt?
Y1 minus k by m y1.
Minus k by m y1 and d y1 by dt y2. So this second order differential equation, with this transformation you can convert it to two coupled first order differential equation. Okay. So our aim is to solve this now. So what you have to give is the initial conditions, y1 of 0 it has to be given and y2 of 0, this also has to be given. So now let us look at the simple method, which is an Euler method. Suppose you have equation like this, f of y comma t. You can approximate this. So what we have to see, we have, so let us forget about this for time being, just look at this, okay, and we have at a time t equal to 0 the value as y of 0. So I want to find out y at delta t, okay. So delta t is the time step. If the time step is very, very small, so this dy by dt, I can write it as, what I can write it as the left hand side?
I of delta t minus y of 0 by delta.
y of delta t minus y of 0 by delta t, which is equal to f this y and t at what time?
Depends on which Eulers.
Yeah. So if it's a forward, y at 0 and t at 0. So from this you can calculate y at delta t as y at 0 plus delta t f of y at 0 t at 0. So using this formula you can calculate y at any time, right, because at a delta t if you know, you can calculate it at any time, okay. But there will be an error. So error will be, which order error you are expecting in this in terms of delta t? Because you neglected the second order terms, right, in the Euler expansion. So delta t square error will be there, okay. So this method you can apply for this problem and you can do the calculation, okay. So one of the ways is you have to solve this coupled differential equations using this Euler method, okay. The second one is the Runge-Kutta method. So I will not explain or derive the Runge-Kutta method. So what you can do is you can look at any numerical algorithm textbook. Maybe most of you have learned it so far in your mathematical course. So here your problem is dy by dt is equal to f yt. And so I will explain this yn plus 1 equal to yn. I will write down the formula directly. So the formula is 1 by 6 k1 plus 2 k2 plus
There must be an H.
where here, right?
Yes, sir.
Yeah. Okay. So what is K1? Okay, I will write down that. So after writing down K1, you have to tell me whether H is there or not. Okay. F this you can take it from any numerical algorithm book, but I just for completeness I am writing it down.
So H is not there.
H is not there. Okay. So you have to calculate this K1, K2, K3, K4. Okay, so basically the fourth order Runge-Kutta method. So So first the function is calculated at Tn. So see earlier I put y0 and yn plus 1 is basically, so any time step, okay. So any time step you can take. So at the time t equal to 0 you can take n is 0. So you calculate y1, y1 is nothing but y0 plus delta t, okay. So this h is, so what is this h? H is basically delta t, okay. So you calculate k1, k2, k3 and k4. So this will give you, so finally you can calculate y at n plus 1, that is if I know y at n, I can calculate y at n plus 1, okay, that is y at, this is the time, okay. So y at 0, then y at 1, that means 1 means h which is equal to delta t, okay, y at delta t and so on. So this is having a better convergence, okay, or error wise, okay, even for small delta t it will give you a better result than a little larger delta t, it will give a better result than this, the Euler method what we discussed earlier, okay. So any question on this k1, k2, k3, k4 and all? Okay. So now we have this Euler method and RK4 method. So now your job is to do our problem, this coupled equation for an initial condition, okay. And what we have to generate is, you have to generate a plot. So first is the energy plot, okay, energy versus time. So three different ways you have to calculate the energy. One is analytically you calculate, you know that it should be a constant. Then using the Euler method, calculate x and x dot. From that you calculate the energy. So that also you plot. Then from RK4, so when you do Euler method and RK4 methods, use the same delta t or h, okay. Then you have to plot it. So then you plot E versus t for the results from which uses the RK4 method. So that is the first plot you have to generate. Second one is the x versus t, okay. The second plot you have to do is x versus t. So that is again analytically you plot, then numerically you both methods, so you will have three plots in this, okay. So Euler, RK4 and the analytical result, okay. So now I will give you just 2 minutes, okay. You think about how do you apply this Euler method and RK4 method for this coupled equation, that you think about now, okay. I will give you just 2 minutes. So now tell me, how do you apply say RK4 method for this coupled equation?
F is a matrix and you take Y as a two-dimensional column vector.
Y as a two-dimensional column vector, okay, then?
F as matrix.
What is X?
F.
F. See, okay, I will tell you something. Right now do not think about generalizing the problem. You can do this problem because it is a, because I want everybody to do this problem initially, okay, that is the reason I am saying this. So right now you don't think about any arrays in your program, okay. So your program should not contain any arrays. For that matter, there is no matrix. Okay. So only variables. So you can do this problem without any array, without any matrix.
Sir, can we have some sort of recursive relation where, in the first, let's say first it finds for dy by 2 by dt, and for that it will need y1's initial condition, but for that it will need y2's initial condition. So again, like it will go on a loop solving first coupled equation. For that, the yn which is required, it will solve the second coupled equation, then back to first coupled equation, like that will go on.
Yeah. So yeah, it will see, that's what it is, a coupled equation, because y2 require y1, y1 require y2. So see here, first thing is you have to understand is this. So this is the function in the right hand side for the first equation, right? This is the function. This function in general can be function of y1, y2, because it is a two variable thing. Okay. So it can be in general, because this particular problem it is only y1, no problem. But in general, two coupled equation, it can be a function of y1, y2 and t. Okay. So that is what generally. And this is also another function which is a function of y1, y2 and t. So it will give function f1, this is f2, and which is a function of y1, y2 and t. Okay. Those two are functions of y1, y2 and t. So now you have to apply this algorithm for that. Okay. So how do you do that? Because this is the place most of the people make mistake while calculating y at any time t and y1 and y2 at any time t. Okay. So people use the past experience, people make mistake at this this calculation, the programming at this level, okay, at this point. So how are you going to calculate k1, k2? So how many k1, k2, k3, k4 are in this case?
Two sets.
There are two sets of k1 and k1, k2, k3, k4. So one k1, k2, k3, k4 for y2 calculation, another k1, k2, k3, k4 for y1 calculation. Okay. So first thing what you have to do is, when you calculate k1, you have to calculate k1 for both y1 and y2. Then go to the calculation of k2. Then go to the calculation of k3 and k4. Okay. Fine.
Yes, sir, because of that h by 2, right?
Yeah, because of, yeah, it is a coupled because of that. Okay. Because so the mistake people have been using is they just calculate k1, k2, k3, k4 for one y1, calculate y at delta t, then they go for the calculation of k1, because that time this y1 is already advanced. So you should not do that. Okay. So you should do it simultaneously. Okay. So calculation of k1, k2, k3, k4 should happen in parallel. Okay. For both y1 and y2. So that is the only thing. Otherwise, so right now if you can do it as a general program, no issue. But because I will be giving another bigger problem which uses a general RK4 algorithm. Okay. General in the case that it is for any number of equations. Okay. Any number of coupled equations, that I will be giving another problem. Okay. So right now, for everybody to do this, you don't have to make a general program, but you should think about how to make your program in a general program, so that your RK4 algorithm is, you should not disturb depending on your program. Okay. I can give you n coupled atoms, they are all interacting each other. Okay, which the interaction can be written down as a coupled different, say under atoms means under differential equations. You know this the famous problem, the Lorentz equations, which shows chaos. So there is a coupled three equations, x dot, y dot, z dot. So the problem may be different, but your RK4 algorithm is same. So that algorithm should not change. So that is a general, I mean, you have to can make it general. Anyway, that you have to do later. But right now, if you are doing it, no problem, but I am not imposing that. But you should start thinking about that. Okay. So any other questions you want to know how to do this problem, or any concern?
Initial condition, it will be entered by the user, right?
Initial conditions, because you have to submit a program, so what I will do is I will give you a common initial condition so that everybody do with the same thing. Okay. So so I'll give you a common, so I give only in the units. Okay. So x0 you can put it in 5 units. Okay. And V0 0. But if I want to change x0 and v0 in the program, okay, so whenever you submit any program, do not submit a program which a user has to give an input. Okay, do not do that. So when I am running the program, it should give you the output. Okay, it should not ask some questions to enter something and all. Okay, that is very crucial. So you give a program which actually should not take any input from the user. It should be there in the built in the program itself. So this x0 value and v0 value should be there in the program itself. So I can go to the program and change the values to get another result. Yeah.
I asked this last time, but how do we submit the things in PDF format is fine, or
Which one?
the answers, the codes?
Codes, whatever code you write, give the code, upload the code.
In PDF or in
No, whatever code. If you are writing a Python, you give the Python code. Okay.
IPIMP file I can see.
Yeah.
Last time I put PDF, so should I upload the code or this time onwards?
Okay, because if you are not uploaded the code, I may give you some because I may extend or something I will do. Okay, you have to upload the code also. Okay.
Okay.
Whatever the same code you have put it in the PDF, you upload the same thing. Okay. Yeah. Then the K and M required. So K and M you can just put 1 unit each. Okay. K is equal to 1 unit, M is equal to 1 unit. And second thing is up to what time you should run the program. That you have to decide by looking at the x of t versus time graph. At least 5 peaks are there. Okay, at least 5 peaks you should be able to see, not more than that. Okay, not less than that. At least 5 peaks should be there in that, or 5 cycles, because it is a periodic thing. Okay, so 5 cycles should be there. So any other information required? So now the question is what delta t. Okay, so you have to choose a delta t very small value, but you have to decide the delta t. Okay, but if you have decided the delta t, you have to use the same delta t for both. Okay, for Euler and RK4. That's very important.
So we are not being put any constraint on how to choose delta t, right? It's my wish, I can do.
You can do that. Okay, so you should not choose very say do not choose anything less than 10 power minus 4. Okay, do not choose anything less than 10 power minus 4. This is not acceptable. Okay. Okay. Otherwise, I will give you delta t values. Choose delta t 0.1, these 3 sets. Okay. So you will have how many graphs? How many graphs?
380.
3 into 2,
One delta.
3 into 2, 6 graphs you should have. Okay. For each delta t, you have one E graph, one X graph. Okay. So there are 3 delta t, so you will have 3 into 2. And each X graph, you will have 3 of them. And each E graph, you will have 3 energies. Okay.
Yes, sir. Understood.
Yeah. Any other question?